The fabric of reality is unraveling before our eyes, and what scientists discovered in 2024 will shake you to your core. Drop a comment below if you think the universe is preparing for something catastrophic, and make sure to subscribe because what I'm about to reveal will change everything you thought you knew about existence itself. Deep within the Arizona desert, the most advanced cosmic surveying instrument ever built has been scanning the heavens for answers. The Dark Energy Spectroscopic Instrument, known as DESI, has been collecting light from millions of galaxies across 11 billion years of cosmic history. What it found wasn't just unexpected, it was terrifying. For decades, scientists believed dark energy was the ultimate constant in our universe. This mysterious force, making up roughly 70% of everything that exists, has been pushing galaxies apart at an ever-accelerating rate. We thought it was stable, unchanging, eternal. We were wrong. The data streaming back from DESI tells a different story entirely. Dark energy isn't constant at all, it's weakening. Over the past few billion years, this fundamental force that governs the expansion of space itself has been losing its grip on reality. The implications are beyond anything science fiction writers ever dared to imagine. Picture standing on the deck of a massive ship that's been sailing smoothly for billions of years. Suddenly you realize the engines aren't just slowing down, they're beginning to fail. That's exactly what's happening to our universe right now, except the ship is all of existence, and there are no lifeboats. Dr. Dylan Brout, the lead researcher on this groundbreaking study, describes the discovery as finding subtle hints that the very nature of space-time might be evolving. And when he says subtle hints, he's using scientific understatement. What DESI actually detected is evidence that the force holding our cosmic destiny together is literally coming apart. If dark energy continues weakening at the rate suggested by the data, our universe could be heading toward one of the most catastrophic events imaginable: a complete reversal of cosmic expansion. Scientists call this scenario the Big Crunch, and it represents the ultimate destruction of everything. Instead of galaxies flying apart forever, they would begin falling back together. Space itself would contract, crushing all matter into an increasingly dense and hot state, until reality as we know it ceases to exist. The timeline for such an event stretches across billions of years, far beyond human comprehension. But the mere possibility that our universe carries within itself the seeds of its own destruction changes everything about how we view our place in the cosmos. We're not just passengers on a cosmic journey, we're witnesses to a potentially dying universe. Michael Levy, DESI's director, emphasizes that these findings are still preliminary. The scientific community demands extraordinary evidence for extraordinary claims, and determining whether dark energy is truly evolving requires years of additional observations. But the initial data is compelling enough to send shockwaves through the physics community. What's particularly disturbing is how this discovery aligns with other recent anomalies in cosmological observations. The Hubble Space Telescope has been measuring expansion rates that don't quite match theoretical predictions. The James Webb Space Telescope has found galaxies that formed earlier and grew larger than current models suggest should be possible. These aren't isolated problems, they're symptoms of a deeper crisis in our understanding of reality. The standard model of cosmology, which has guided scientific thinking for decades, is showing signs of strain. If dark energy is indeed evolving, it means we need to completely rethink the fundamental laws governing the universe. The implications extend far beyond academic physics. Every technological advancement, from GPS satellites to particle accelerators, depends on our understanding of how space and time behave. If the underlying structure of reality is more fluid than we thought, it could revolutionize everything from quantum computing to space travel. Consider how GPS works. It relies on extremely precise calculations based on Einstein's theories of relativity. These calculations account for how gravity affects time and space. If space itself is evolving in ways we don't fully understand, even our most basic technologies might need to be reconsidered. The DESI collaboration involves over 900 researchers from around the world, making it one of the largest scientific endeavors in history. The instrument itself is a marvel of engineering, capable of simultaneously observing 5,000 galaxies with a precision that boggles the mind. Each observation requires accounting for countless variables, from atmospheric distortions to the gravitational effects of nearby objects. What makes the dark energy findings so significant is their statistical weight. This isn't based on a handful of observations or theoretical speculation. The conclusions emerge from analyzing millions of data points collected over years of continuous observation. The pattern suggesting evolving dark energy appears consistently across different time periods and regions of space. The technical term scientists use is quintessence, a dynamic form of dark energy that changes over time. Unlike the cosmological constant that Einstein originally proposed, quintessence would have its own internal dynamics, potentially influenced by quantum effects we're only beginning to understand. This brings us to one of the most mind-bending aspects of the discovery. If dark energy can evolve, what's driving that evolution? The answer might lie in the quantum nature of empty space itself. What we think of as vacuum might actually be a seething ocean of virtual particles and fields, constantly creating and destroying matter at scales smaller than atoms. These quantum fluctuations could be interacting with dark energy in ways that cause it to decay over cosmic time. The energy might be leaking away into dimensions we can't directly observe, or transforming into other forms that don't contribute to cosmic expansion. Either possibility would fundamentally alter our understanding of how the universe works. The discovery also raises profound questions about the multiverse theory. If our universe's dark energy is evolving, what about other possible universes? Could some have already undergone their own Big Crunch scenarios? Might others be experiencing even more rapid expansion, tearing apart not just galaxies but individual atoms? From a philosophical standpoint, the implications are staggering. Humans have always lived with the knowledge that individual lives are temporary, but we've generally assumed the universe itself would continue indefinitely. The possibility of cosmic mortality adds an entirely new dimension to existential questions about meaning and purpose. The research team is being extremely careful about their claims, as they should be. Science progresses through rigorous verification, and extraordinary claims require extraordinary evidence. But the preliminary data is strong enough that other research groups are racing to confirm or challenge the findings using independent methods. Ground-based telescopes around the world are being repurposed to gather additional data. Space-based observatories are adjusting their observation schedules to focus on the specific types of measurements that could validate the DSC results. The scientific community is mobilizing resources on a scale rarely seen outside of major crises. What's particularly fascinating is how this discovery connects to other mysteries in modern physics. Dark energy was already one of the biggest puzzles in science, making up 70% of the universe while remaining almost completely mysterious. Now it appears even more complex and dynamic than previously thought. The relationship between dark energy and dark matter, another cosmic mystery comprising about 25% of the universe, might also need to be reconsidered. If dark energy is evolving, it could be interacting with dark matter in ways that influence the formation and behavior of galaxies and galaxy clusters. Recent observations have shown that galaxy formation in the early universe proceeded faster than current models predict. Massive galaxies appeared when the universe was younger than theoretical frameworks suggest should be possible. A changing dark energy field could provide the missing piece of this puzzle. The James Webb Space Telescope has been finding fully formed galaxies at distances corresponding to when the universe was less than 500 million years old. These observations challenge our understanding of how quickly matter can collapse under gravity to form stars and galactic structures. An evolving dark energy field might explain these anomalous observations. Temperature measurements of the cosmic microwave background radiation, the afterglow of the Big Bang, also show subtle patterns that don't perfectly match standard cosmological models. If dark energy has been changing throughout cosmic history, it would have left distinctive fingerprints in this ancient radiation that we're only now learning to decode. The technological challenges involved in making these measurements are almost incomprehensible. DESI observes light that has been traveling for billions of years, requiring instruments sensitive enough to detect individual photons while filtering out countless sources of interference. The precision required is like measuring the width of a human hair from a distance of several miles. Each galaxy's redshift must be measured to extraordinary accuracy, accounting for its motion through space, gravitational effects from nearby objects, and the expansion of space itself. The calculations involve general relativity, quantum mechanics, and statistical analysis techniques at the cutting edge of mathematical physics. The supercomputers processing this data work continuously, analyzing patterns across multiple dimensions of space and time. Machine learning algorithms trained on theoretical models help identify subtle signals that might indicate evolving dark energy. The computational requirements are so intense that the project consumes more processing power than many entire countries. What emerges from this technological symphony is a picture of a universe far stranger and more dynamic than we ever imagined. Instead of the steady, predictable cosmos described in textbooks, we're discovering a reality that's constantly changing, evolving, and potentially heading toward an ultimate transformation. The social and cultural implications of these discoveries are only beginning to be explored. How do we process the idea that the universe itself might be mortal? What does it mean for human purpose and meaning if all of existence is temporary on a cosmic scale? Religious and philosophical traditions will need to grapple with these new scientific insights. The concept of eternal cosmic laws is being challenged by evidence of fundamental change at the deepest levels of reality. This intersection of cutting-edge science and ancient questions about existence promises to generate debates for generations. Educational systems will need to be updated as our understanding of cosmic evolution becomes more sophisticated. Students learning about the universe today are receiving information that might be fundamentally incomplete or incorrect based on these emerging discoveries. The economic implications are also significant. Industries ranging from satellite communications to fundamental research depend on accurate models of how space and time behave. If these models need major revisions based on evolving dark energy, it could trigger technological innovations and disruptions across multiple sectors. As we stand at this cosmic crossroads, one thing becomes clear. We're living through a pivotal moment in human understanding. The Deci discovery might be remembered as the point when our species first realized that the universe itself has a history more complex and dramatic than we ever dared imagine. The journey ahead promises to be extraordinary. Additional observations over the coming years will either confirm that dark energy is indeed evolving, or reveal that the initial signals were misleading. Either outcome will teach us something fundamental about the nature of reality. If confirmed, the discovery that dark energy weakens over time would represent the biggest breakthrough in cosmology since the initial detection of cosmic acceleration in 1998. It would mean that the universe's fate isn't sealed, but continues to be written by forces we're only beginning to understand. The story of cosmic evolution is far from over. In fact, we might be witnessing just the opening chapters of a much more complex and fascinating tale than anyone previously imagined. The universe isn't just expanding, it's evolving, changing, and potentially preparing for transformations beyond our current ability to predict. What happens next depends partly on continued observations, and partly on theoretical breakthroughs that might explain why dark energy behaves the way it does. The coming decade promises to be one of the most exciting periods in the history of cosmology, as we work to decode the deepest secrets of existence itself. The leaked cosmic discovery isn't just changing science, it's changing our fundamental relationship with reality. We're no longer passive observers of a static universe, but witnesses to a cosmic drama still unfolding around us. The next chapter of that drama is being written right now, and for the first time in human history, we have the tools to read it as it happens.